So up until now, we've just talked about the general idea about using linked nodes and how we can manipulate them. And you should make sure you have a really strong understanding of all of that material before you move on to sort of the second half of the material, in which we'll talk about actually using linked nodes to implement the collections we've been talking about, a list and a bag. But it's really important to understand first just what nodes are and how to work with them, and make sure you understand just the concept of nodes and how to use them before moving on to looking at how we're going to use them in our actual classes. So again, you can kind of think about this as like part A and part B. Part A is just all about nodes, and now we're going to be beginning part B, where we're going to talk about actually using nodes to implement collections. So in general, let's keep in mind some of the differences we've talked about with arrays versus linked nodes. Array-based implementations have some disadvantages. So one disadvantage is the need to shift for insertions and deletions. So if you're inserting or deleting from the beginning or the middle, there's a lot of shifting that needs to happen to either make room for the new element or to cover up the space left by removing an element. And this shifting is not very efficient. So this is a disadvantage of using arrays. There's also the disadvantage that because arrays are a static data structure, if our array fills up, we have to deal with that. And one way to deal with that is by copying the contents over to a new bigger array. But of course, that is also not efficient because we have to go through our entire array every time we need to make more space and copy it over. And then there is also the potential disadvantage of just creating a very large array, but then having a bunch of wasted space. So this can be very difficult, particularly in problems where you don't ahead of time have a good sense of what size of data structure you'll need. So you can't make a good initial estimate of how big to make your array. It might result in you either having to, expand it many times or have a lot of wasted space. So this is one of the disadvantages of arrays. These particular disadvantages can be avoided with linked nodes. We've seen that if we're doing a lot of insertion or deletion at the beginning of a list, linked nodes are great for that. In the middle, the story is a little bit more complicated. We also have seen that linked nodes are a dynamic data structure. That means we don't have to specify up front how many elements are going to be in our collection. So we don't have to specify the size. We just add on new nodes as needed or remove nodes as appropriate, and the size of the collection grows and shrinks. Okay. Of course, there are also disadvantages of linked nodes, right? The main obvious one being that we don't have direct access to any individual element. So with an array, we can say, give me the 10th element on the list. With linked nodes, we can't. We'd have to iterate through updating current node 10 times. Okay, so that's kind of the main glaring disadvantage with linked nodes. So keeping those in mind, let's see how our implementations would look for our list and our bag using nodes. So just like we did with an array, we're going to look at the classes that we'll use to implement those two interfaces. So for any class, of course, again, we start with our instance data variables. For a bag, we're going to have two variables. We're going to have a node, and our textbook calls it first node. Again, another common name for that is head. And we'll have another variable for number of entries, right? So we still do need to keep track of how many elements we've got in our bag. The constructor will initialize these things. Note that first node will be initialized to null because first node being null is how we represent an empty collection, an empty bag. So this is again why in particular we're dealing with linked nodes, you always have to account for potential crashes because of null, okay? Sometimes after this lesson, people sort of overgeneralize and they start putting null checks in their code for everything, for arrays and for all other sorts of things. For most other kinds of objects, we don't usually check for null. If something is null, it really is an error, and we probably do want the code to crash in many cases. But with linked nodes, something being null is actually an expected occurrence. If first node is null, it just represents an empty bag. So it's not an unexpected thing. Our code shouldn't crash under that condition. And if we do think that whatever task we're trying to take, throwing an exception is the right thing, like let's say someone tries to remove an element from an empty bag, and we are going to say our decision is going to be, if someone tries to do that, I'm going to throw an exception because that's not allowed. So that's okay, but the type of exception shouldn't be null pointer. It should be, illegal argument or something, unsupported operation, something like that, something more informative about what went wrong. So you never want your node code throwing null pointer exceptions, okay? And again, with nodes, null is an expected occurrence. Anytime your bag is empty, your first node's going to be null. Also, you're always going to have a null as your last next, right? You've got a node dash next dash next dash next, and then that last node in the chain, its dot next is null. So the nulls are expected, so you got to account for them. Now again, we're only keeping track of that single node to keep track of the entire chain. Okay, so that single node, first node points to the first item, and then that first item will point to the next, then second to the third, and so on and so on. So we're keeping track of that single node with our named instance data variable, and by doing so, we maintain access to all elements if we were to iterate through that chain. So let's talk about the functionality of a bag. Remember that bags are unordered collections. We do not have to maintain the order. So when we add something to the bag, we don't have to worry about order. So since order doesn't matter, let's do what we did for an array. Let's choose to add in the easiest place since order isn't important. For an array, that was adding at the end, right? The last open space. For linked nodes, the easiest place to add is at the beginning. So when we're adding to a bag, let's just add on to the beginning of our chain. That's the easiest way. And again, of course, we have to pay attention to adding to an empty bag or a singleton bag. Removing from a bag. Well, the bag interface gives us two ways to remove. One is to remove some unspecified element, just take something out of the bag. Again, this specified method doesn't specify which element we're removing, so let's again pick the easiest one. For linked nodes, easiest thing to do is just to remove the first. And again, make sure you're checking for special situations. In this code in particular, the empty bag case, it will crash, so you need to account for that. The other remove method in bag interface is removing a particular element. So our approach here is we first have to make sure the bag's not empty, and then we have to make sure the bag actually has that value. Okay, so we'd have to iterate through the bag to see if any one of the elements in our chain is the value we're looking for. Once we find that value, we can then use the process we talked about earlier for removing that from the middle, or the end, or wherever it shows up. Or what we could do, which could be even easier, is because we're dealing with a bag here, and again, order doesn't matter, another approach is just to say, okay, once I find the element I'm looking to remove, let's just swap the data with the first node of the chain and then delete that first node. That might be a little easier. So this is actually the approach that the book is going to take, and we'll look at that in the code in a moment. But note that we could use that same process that we used before. That would be a totally valid way of removing from a bag. And it's just a different design decision. Then there are other methods that don't modify the bag, right? The add and the remove are what allow us to change the state, but there are other methods that provide information but don't alter the state. These methods will rely on traversing the chain, again using that temporary node. So a current node or a temp node, looping through till the node is not null, doing whatever we're doing with each node, and incrementing or updating that current node reference as it goes along. Okay, so let's actually take a look through the actual code of our linked bag class.